The JavaScript Fetch API is a modern way to make hypertext transfer protocol requests. It offers a powerful and flexible alternative to the older XML HTTP request method. It is built on promises, which makes it great for handling asynchronous operations. This allows for cleaner, shinable syntax and better error management. The Fetch API is a standardized way to make HTTP requests in the browser. It is a web standard and it replaces the older XML HTTP request with a more powerful and flexible API. The Fetch application programming interface provides a simple way for making hypertext transfer protocol requests. By default, it makes a GET request to the specified uniform resource locator. The fetch function returns a promise that resolves to the response object, which represents the response to the request. You can use .then to handle the response and transform it into the format you need. In the code example, a basic GET request is made using fetch. The response is then checked to see if it's okay. If not, a new error is thrown. If it is okay, the response is converted to a JSON object. Finally, the data is logged on the console. In case of an error during fetch operation, the error is caught and logged on the console. The Fetch API allows you to configure your requests with various options. These options can be passed as a second argument to the fetch function. The method option specifies the hypertext transfer protocol method, such as get, post, put, or delete. The headers option allows you to specify custom HTTP headers for authentication, content type, or other purposes. The body option specifies the request payload. For JSON data, you need to stringify the data. Other options include mode and credentials. Mode is used for cross-origin requests, and credentials are used for authentication. In the code example, a post request is made with custom configuration. The method is set to post. The headers are set to content type application JSON, and authorization with a bearer token. The body contains the title and content, and it is converted to a JSON string. Mode is set to cause and credentials is set to include. The Fetch API provides several methods to process the response based on the content type. These methods allow you to convert the response body into a usable format. If the content type is application JSON, you can use the .json method to parse the response body into a JavaScript object. If the content type is text plain, use the .text method to read the response body as plain text. If the content type is application octet stream, use the .blob method to return the response body as a binary blob object. If the response is in form data, you can use the .form data to parse the response as form data object. In the code example, the fetch request is made to an API. The content type of the response is checked, and accordingly the method is called to convert the data to a usable format. Error handling is an important part of any fetch request. The fetch function only rejects on network failures, not hypertext transfer protocol errors. Therefore, you need to check the response.ok property to see if the response is successful, and then throw an error. Network errors occur when a request fails due to network issues. This is caught in the catch block as type error. HTTP errors occur when the server responds with an error status such as 400 or 500. These must be checked via the response.ok property. In the code example, an asynchronous function fetch data is created which takes a uniform resource locator as input. Inside the try block, a fetch request is made, and then the response is checked using response.ok property. If there is an error during response, then a new error is thrown. If the response is okay, then the response is converted to JSON and the data is returned. If a type error occurs, then a network error is logged on the console. If there is some other error, then that is logged on the console. Finally, the error is rethrown to allow the caller to handle the error. Using asynchronous and await with fetch makes asynchronous code look and behave more like synchronous code. It helps in managing flow control for sequential, parallel, or conditional requests. It also makes debugging simpler by providing more meaningful stack traces. Additionally, It allows the use of traditional try-catch blocks for error handling. In the code comparison, the asynchronous fetch user data function uses the await keyword to handle the promise returned by the fetch function. The response is first awaited, then it is converted to JSON and returned. Any error during the fetch process is caught and logged in the catch block. Using the async function, the user data is logged on the console. Async await makes asynchronous code easier to read, write, and debug. The Fetch API allows you to use different hypertext transfer protocol methods for various types of requests. The POST method is used to create a new resource on the server. It sends data in the request body. The PUT method is used to update an existing resource. It replaces the entire resource with the new data. The patch method is used to partially update an existing resource. It only sends the changed fields. The delete method is used to remove a resource from the server. It does not usually need a request body. In the code example, two asynchronous functions are created, one to create a new user and the other to update an existing user. The create user function makes a POST request with content type application JSON. The update user function makes a PUT request with content type application JSON. It is important to always set the appropriate content type header when sending data. The Fetch API, combined with the Form Data Application Programming Interface, provides an easy way for file uploads. The Form Data object automatically sets the correct content type and handles file boundaries. Multiple files can be appended to the form data using the same or different field names. It is important to validate file types and sizes, both on the client and server sides. The Fetch API can handle both blob and file objects using built-in form data support. In the code example, an asynchronous upload file function takes a file as an input. A form data instance is created and the file is appended to the form data. Then, a POST request is made to the API with the form data as the body. The response is checked for any error. If an error occurs, it is logged and rethrown. An event listener is added to the file input, which calls the upload file function whenever a file is selected. Note that if you need to track upload progress, you should use XML HTTP request instead of fetch. The Fetch API provides some advanced features to help manage complex requests. The abort controller allows you to cancel requests that take too long. This can be used to implement request timeouts. You can also configure how the browser caches responses using the cache option. The credentials option allows you to handle cookies and authentication. The Headers API provides a powerful interface to manage request and response headers. In the code example, an abort controller is created, and a timeout function is set. If the request takes more than 5 seconds, then the request will be aborted using the abort controller. Various headers are set like authorization, accept, and custom header. The credentials is set to include, and mode is set to coerce. The cache is set to no cache. In the catch block, it is checked if the error is an abort error, and if it is, then request timed out is logged on the console. When setting the timeout value, set it according to your API's response time. To make the most out of the Fetch API, it is recommended to follow some best practices. Create a reusable API client to handle common configurations and error handling. Always check the response status and handle errors consistently. Set appropriate security headers and use HTTPS for all requests. You should also use appropriate cache strategies and consider implementing request queuing for better performance. In the code example, an API client function is created that accepts an endpoint and options as input. The default options are set for headers, credentials, and timeout. An abort controller is created, and a timeout is set. The fetch request is made with default options and the options passed as input. The response is checked for errors using the check response status method, and the response is converted to JSON and returned. Any errors that occur are handled using Handle API Error method. Always use a reusable wrapper, check for errors, and set appropriate security headers. If you like this video, Hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.